We want to sketch a graph of the polar equation r equals sine of 2 theta. To do that, we will graph y equals sine of 2x first. This equation is obtained by writing r as y, theta as x. We will graph y equals sine of 2x in a rectangular coordinate system. Period of this equation is 2 pi divided by the number in front of x, which is 2, so period is pi. This determines the key points. Key points are 0, pi over 4, pi, 3 pi over 4, and pi. Maximum of this graph is 1, and minimum of this graph is -1. If we graph the function according to the information, then we obtain this graph. Maximum is 1 and minimum is -1 and period is pi. But the graph should contain at least 0 to 2 pi because we will use it for polar equations graph. Let's graph r equals sine of 2 theta. In this picture, I embedded polar coordinate system in the rectangular coordinate system. Let's label with the angles. This polar x-axis can be interpreted as angle 0 or 2 pi. This dotted angle is pi over 4. This positive y-axis is pi over 2. And this one is 3 pi over 4. And this is pi. And this is 5 pi over 4. This is 3 pi over 2. This is 7 pi over 4. If you look at the graph here, it starts from 0, 0. So it passes here. When angle varies 0 to pi over 4, the distance between the origin and the point on the angle will become larger and larger, and when it becomes pi over 4, the distance will become 1. So angle varies this way, the distance will increase and eventually become 1. So the graph will look like this. All the points are located on the terminal side of the angle because y has a positive value. Between pi over 4 to pi over 2, when angle varies, the distance between the point and the origin will decrease and eventually become 0. Because of that, the graph will look like this. When angle varies between pi over 2 to pi, the distance is negative. So the points are located on the opposite side of the terminal side. When angle varies pi over 2 to 3 pi over 4, the original angle terminal sides are located here, but distance are negative. That means we have to go opposite. So when we go this way, we go the other way. So this way, if we go opposite, then we go this way. So it starts at 0, and distance between the origin and the point will become -1 when the angle is 3 pi over 4. When we go opposite, that becomes 7 pi over 4. So we will land at this point, and we do the same reasoning as we discussed in this leaf. And that part looks like this. The angle varies from 3 pi over 4 to pi. Then angle will vary from here to positive x-axis and eventually become 0. That means that part will look like this. In the region 3, the graph is above y-axis, meaning all the values are positive and all the points will be located on the terminal side of the angle. So we think about the angle ranges between pi to 5 pi over 4. So we go this way. We start from 0, and the distance between 0 and the point on the angle 5 pi over 4 will be eventually 1. So that part can be expressed in this way. When the angle varies between 5 pi over 4 to 3 pi over 2, angle varies in this way, and the distance starts from 1 and decreases and eventually become 0. So petal look like this. between angle 3 pi over 2 to 2 pi, y value become negative again. That means points are located on the opposite side of the terminal side of the angle. So when angle varies between 3 pi over 2 to 7 pi over 4, the opposite side angle will be located here and moves this direction, and the distance will be opposite. The distance will be 1, but opposite of the angle direction 7 pi over 4. So we go this way, the distance is 1, and the points varies in this way. When angle varies from 7 pi over 4 to 2 pi, the angles are located here. When we move this direction, in the opposite part, the angle moves this direction. So it starts from distance 1 and eventually becomes 0. So this is what we get in region 4. This was region 3. This graph is so-called a rose. Rose with 4 petals. Let me describe the general equation of rose. The general equation of rose is R equals A cosine of n theta, or R equals A sine of n theta. Of course, we are assuming A is not equal to 0 and n is a natural number. The natural number n determines the number of petals. If n is odd, then number of petals is n. If n is even, then the number of petals is 2 times n. In this example, this is the equation of rose. This is an even number. So the number of petals became 4, twice bigger than that number. The next one is just about the exercise for you. Graph R equals 5 sine of 3 theta. This is an equation of rows. With 3 petals. That's because in the equation, the number in front of theta is an odd number. When that happens, the number of petal is that number itself. I will not explain how to draw the graph, but I will give you a hint. In the first step, you will graph y equals 5 times sine of 3x. In this case, period is 2 pi over 3 and maximum is 5 and minimum is minus 5. And key points are 0, pi over 6, pi over 3, and pi over 2, and 2 pi over 3. If you graph that, then you will get this graph. Maximum is 5 and minimum is negative 5. Before you graph that, you will label with the region. This time, this is 1. This region is 2. This region is 3. This part is 4. This is 5. And this is 6. After that, if you draw the graph in a polar coordinate system, then you will realize that it'll go back to the original point. By using this graph, if you graph the polar equation, y r equals 5 sine of 3 theta, then you will obtain this graph. We will start at 0 and the distance will become 5. And as angle increases, the distance will increase and eventually become 5. And then angle increases from pi over 6 to pi over 3. Then the distance will decrease to 0. And between angle pi over 3 to pi over 2, the distance is negative. So angle changes from here to here, but we go opposite. So we go this way. And then it starts from 0 and the distance increases until it becomes 5. and then it starts to decrease and become 0, and so on. This is the rose with 3 petals.